Define malleable and explain why metals have this property. So malleable means that metals can be struck or hammered into different shapes without breaking that giant metallic structure. So if we have a look at what a giant metallic structure is, I've drawn one on the screen, and we can see that this giant metallic structure is made of these regularly arranged positive ions or cations with this sea of delocalized electrons. And delocalized means that they're free electrons. So let's imagine that this giant metallic structure is sodium. We know that sodium is in group 1, and that means it has one electron in its outer shell. So for every positive cation, there is one electron that is free in its outer shell. It has lots of energy, and that's why it's delocalized. So to explain malleability and why metals have this property, let's take a hammer and strike our metal. So now if we draw the structure, it would look a bit like this. And we can see that this metal is still held together, although the shape has changed. And the reason for that is these electrons. These electrons are like glue. They're holding that structure together and stopping that structure breaking into small pieces. The reason I say it's like glue is because they're what cause the electrostatic attractive forces between the positive cations and the negative electrons. Without those electrons, the cations would repel. So the reason why a metal is malleable is that these layers of cations can slide over one another, therefore making a new shape of a metal without breaking that structure into pieces because of those electrons, meaning that there's still those electrostatic attractive forces between the cations and the electrons.